In this video, we're going to focus on the slope of linear functions, and I'm going to go back to section 2.3 in your textbook, and we're going to look at some of the examples that you've actually already worked with back in section 2.3. So if you want to follow along with me, you can find these problems starting on page 136. But let's go back to the definition of a slope. We are told that the slope is the ratio of the rise to the run of a line. It also measures the steepness of that line, and the slope also represents the change in y for every unit change in x along that line. So basically, the slope tells us how the function changes, and when we say change, you want to be specific about that change. You want to indicate that that change is either an increase or a decrease. So the slope tells us how the function increases or decreases as x increases by one more unit. So let's first look at let's look at problem 5. So in problem 5, we were dealing with the number J measured in thousands of cans of frozen orange juice sold weekly, and we're told that that is a function of the price, P, in dollars of a can. So we are given this beautiful formula down here, J is equal to 11 minus 2.5 P. And what I want you to do for each of these problems is I want you to first identify the slope. So what is the slope for each of these examples? And then let's write down the meaning of the slope in the context of the problem. So again, our two variables here are number of cans of frozen orange juice sold weekly and the price. So if we take a look at this equation, you can see that the equation is written in slope-intercept form, but I'm going to reorder it just a little bit. So I'm going to rewrite this as negative 2.5p plus 11. So hopefully you can see clearly that the slope is negative 2.5, and then if we wanted to talk about the y-intercept, then you can see that the y-intercept is positive 11. But let's just focus on the slope for right now. So the slope here is negative 2.5. Now let's talk about what it means in the context of the problem. So this slope of negative 2.5 tells us that the number of cans of frozen orange juice, remember that's J, okay, sold weekly. So remember that's your J, decreases, and I know it's decreasing because of that negative slope, and it decreases by 2.5 thousand cans. And I know that it's 1,000 cans because that's the unit for J, right? And J decreases by that amount when the price, which is P, increases by an additional $1. So every time the price goes up by $1 or by one more dollar, we can expect that the number of cans of orange juice sold is going to go down by 2.5 thousand cans. Okay? Let's take a look at example 7. The resale value V in thousands of dollars of a boat is a function of the number of years T since the start of 2011. And we're given another beautiful formula. V is equal to 12.5 minus 1.1 T. Again, I'm going to rewrite this in slope-intercept form so that you can easily identify the slope. So when I write it like this, and remember that I haven't changed the meaning of the function. So 12.5 minus 1.1 T is the same thing as negative 1.1 T plus 12.5. But when I write it in slope-intercept form, I can see that the slope is negative 1.1. So now let's write down the meaning. So this tells us that the resale value, let me spell that correctly, resale value, remember that's V. So the resale value of a boat decreases. The slope tells us that it's going to decrease, and again, I know that because the slope is negative, and it decreases by $1.1 thousand, and I know that it's thousands of dollars because again, that's the unit for V. So thousands of dollars every year after 2011. So this slope is telling us that every year, starting at 2011, the resale value of that boat is going to go down by $1.1 thousand. Okay, let's take a look at the next example. So let's take a look at 9. The distance d in miles that you can travel without stopping for gas depends on the number of gallons of gasoline in your tank and your gas mileage, which we're calling M, that your car gets. And then we're given this formula, D is equal to G times M. Now notice that this formula is different from the first two formulas in that we don't actually have numbers here. But this is a linear function, and I'm going to rewrite this in slope-intercept form so that you can see that the intercept is actually 0. So would you agree with me that this is the same thing as D is equal to G times M plus 0? Okay, so if I write it like this, we can see that the slope is G. So a slope of G means that the distance you travel without getting gas, travel without stopping for gas, increases, and I know that it's going to increase because the slope is positive, increases by some G, so G can be any number, increases by G miles, and I know that my unit is miles because the distance that you can travel is measured in miles. So the distance traveled without stopping for gas increases by G miles for each additional number of gas mileage. Remember, that's M that your car gets. And that seems to make sense, okay? For each additional gas mileage that your car gets, your distance is going to go up by some number of miles, depending on how many gallons of gas that you put in, right? Okay. Let's take a look at the last example, and I'm just gonna take a look at this equation here. You can do this one on your own. But here we're told that P stands for the price measured in dollars per bushel for some barley, and S stands for the quantity of barley measured in billions of bushels. So here it's already written in slope-intercept form, so we can clearly see that the slope is positive 1.9. And so this 1.9 tells us that the price, it means that the price per bushel of barley increases, and again I know it's going to increase because my slope is positive, and it's going to increase by $1.90 for each additional billion of bushels or billion bushels produced by the supplier. And that makes sense too, right? For each additional billions of bushels that the supplier produces, the price is going to increase by $1.9 or $1.90. Okay, I hope that you found that helpful. Another way to also understand the meaning of a slope is what you can do is you can write the slope as a ratio. So I'm going to write every single slope as a ratio by putting it over 1. And then what you want to do is you want to write the unit. So remember that the slope is the change in your output divided by the change in your input. So for this problem, the output is J and the input is P. So what's the unit for J? The unit is thousands of cans, and then the unit for P is dollars. So you can think of this as thousands of cans per dollar. Okay? For this second example here, We have the change in V divided by the change in T. So V, its unit is measured in thousands of dollars. So thousands of dollars. And T is measured in years. So this slope tells us the decrease in thousands of dollars per year. And then let's just go to this last example here, number 11, right? The slope represents the ratio of the change in P over the change in S, and P is measured in dollars, okay? And S is measured in billions of bushels. Billions of bushels. Okay, and we're talking about barley. So the slope is telling us that the price is going to increase by $1.9 per billion of bushels of barley. So I hope that you find that helpful.